So the essential question, how will we add or subtract rational expressions? We're actually going to do this similar to how we add and subtract regular fractions, rational numbers. You just got to remember, how did we used to do it, and now how can we generally do it? No matter what we're looking at, how could we add something that looks like a fraction? So in the first case, in order to add or subtract rational expressions, you must first have a common denominator. Then we add or subtract the numerator and keep the denominators the same. Finally, we're going to try to reduce the fraction. Let's simplify the fraction. Let's just review on how we used to do it. You had to figure out a common denominator. And I'm going to describe it as when you figure out your common denominator, sometimes teachers use the jargon of find your least common denominator, or LCD. And I'm going to put it in a phrase in general. You got to break up the denominator, look at the factors that they have and in common, and look at the factors that they don't have in common. Whatever they don't have in common is what we're going to have to multiply the numerator by in order to get a common denominator. For example, in the first fraction, the denominator is a 2 times 2. In the second fraction, the denominator is a 2 times 3. What do they not have in common? They don't have a 2 in common, and they don't have a 3 in common. So what I'm going to have to do is multiply the first fraction by the 3 that's missing, multiply the second fraction by another 2. This is how we get the common denominator of a 12. So I've got 9 and 2, answer's 11/12, and I cannot reduce it, so that's my answer. So they're actually already broken down in their prime factors. So we're going to multiply each numerator by the other one. So if I see a binomial in the numerator, I'm going to put parentheses around it, because you're going to have to multiply 5 times each of those, and then we'll have to multiply x times the monomial 2x. So it becomes all over the common denominator, 5x. Distribute the 5, getting 15x plus 40 minus 2x squared. So I'm going to write my answer in descending order of powers, starting with negative 2x squared plus 15x plus 40. We should always check to see if we can reduce. The thing about this is, in order to get a reduced fraction using a 5x, you have to have a greatest common factor of the monomial 5x. But this trinomial does not share a common factor of 5x, so it won't reduce. Even if we tried to factor, because it does not have the greatest common factor of 5x, it won't reduce. So we stop. Alright, so in the next one, I'm going to factor x squared minus 5. So before I try to figure out what do they share, what do they not share, accidentally skipped example 3. What I'm going to do is I'm going to break up 6x squared into its prime factors and realize that x squared is also x times x. Some of you may need that written out, may not. But then in the next one, they both share a 4x, but 4 gets broken down in a 2 and 2 and an x. If I take out 4x, I'm left with x minus 3. Break it down, the denominators, in their prime factors. So the reason why we break it down in complete primes is we can see what they share and what they don't share. Whatever they don't share is what I'm multiplying their numerators by. So we have a 3 times 2 times x, and you've got to figure out, well, what does this one have that this one doesn't? Because that's what I'm going to multiply 5 by. So hold on, we've got a lot of questions popping up in class. You break it down into its prime factors. The way you find a least common denominator is figure out what do they share, what do they not share. Maybe we need to write it out. They share the denominators, or they share a 2 and an x. What they don't share is a 3, another x, and then a 2, another 2, and an x minus 3. So after highlighting what they share and what they don't share, so this numerator is going to be multiplied by a 3 and an x. This numerator, the 5, is going to be multiplied by a 2 and an x minus 3, because that's what it is missing. All right, so we're going to multiply 5 times a 2 and an x minus 3. We're going to multiply the x times what it's missing, which is a 3x. When I write down the numerator, I'm actually just going to distribute a 10. So notice where I'm pointing. 5 times 2, I'm going to distribute a 10. So getting 10x minus 30. Some of this is mental math. 10x minus 30, and then plus 3x squared. So the monomial for the least common denominator is 2x times 3x times 2. So we've got 12x squared as the monomial part, and I'm just going to leave the binomial x minus 3. That way it cleans it up. Numerator, I'm going to write in descending order. And let's see if we can reduce. It does not seem like they all share the same factor, so I can't reduce with this 12x squared, but what about the x minus 3? What multiplies to negative 90 adds to 10? So after trying to figure out, after trial and error, we don't see if that can break up, that numerator. All right, so in the next one, what we're going to do is figure out the factors of each denominator, figure out what do they share, what do they not share, because it's what they don't share that we're going to multiply the other numerator by. So after factoring the first denominator, factor the second denominator. Let's notice what they share. They share x plus 3. But what they don't share is another x plus 3 and an x minus 3. So if I just wanted to look at a common denominator right away, what they share is an x plus 3. What they don't share is another x plus 3 and an x minus 3. So the numerator, x plus 1, will be multiplied by x minus 3. The numerator, I'm going to include the negative here. Negative 4, or minus 4, is going to be multiplied by x plus 3. When I write down my new numerator, I'm going to completely double distribute and include the distribution of the 4 with the negative symbol, the minus sign. First numerator, and then I'll distribute the negative 4, so minus 4x minus 12. If you don't include the minus sign, you're going to forget that 12 is also being subtracted. See if somehow, oops, I boxed it too early. Can we multiply to negative 15, add to negative 6 somehow? Can't happen. So now let's go on to 5 and 6. Going back to Tuesday, 5 minus x looks uber similar to x minus 5. They're opposites. So we're going to use the same idea. If you ever see this, I'm not going to trip you up on the test with this, but I do need you to be exposed. If you have two factors that look uber similar, but they're not the exact same, they're completely opposite, let's change, or let's take out a negative in that denominator. When you take out a negative, it changes the operation. So it's no longer going to be subtraction. It's actually going to be addition of x minus 5 in the denominator. We share an x minus 5. What we don't share is this x plus 5, and that's what I'm going to have to multiply the second fraction by, is an x plus 5. So again, common denominator entails what they share and then what they don't share. I've got a 6 plus, let's distribute 2x plus 10. We are going to do the last example because we notice, hey, wait a second. They share the x plus 3. That means you have a common denominator already. I don't have to multiply the numerators by anything. So 6 plus 2x, I'm going to put the x term first. 2x plus 6 over x plus 3. See if you can reduce. And the thing about this is if I do take a 2 out of the numerator, I'm left with x plus 3 and an x plus 3. This is the first example that we do get a reduced answer. Tomorrow we're going to start with the backside.